I'm Dr. Peter Gerasalo, the Principal Investigator and Program Manager for Arete's Now-C Topic N68335-21-C-0545 program developing HANA, an electromagnetic turbulent velocity sensor. Arete, founded in 1976, is an employee-owned small business with offices around the country. Our name is Greek for the concept of excellence, and we harness the world-class talent of our employee owners to provide superior solutions to national and global security challenges from seafloor to space. We work from first principles to design, develop, and deliver high-performance sensors and algorithms to our customers. Over the past 48 years, Arete developed core competencies in detecting weak signals in heavy clutter with low false alarms over wide areas of interest, performing detailed physics-based modeling, developing low-slop sensors with real-time processing capabilities, multi-domain sensor data fusion, extracting maximum performance from existing deployed systems, and rapid prototyping and production. Turbulence is ubiquitous in the ocean, but the Navy does not have a way to persistently measure small-scale turbulent velocities. The Navy is interested in a sensor that will survive in the ocean for at least 3 months, but preferably longer, and has sampling characteristics which allow it to resolve the smallest scales of turbulence from underwater vehicles at high speeds. To measure small-scale turbulence, we typically use small sensors like a shear probe shown in the lower right corner of this slide. These sensors have excellent performance but low survivability in the ocean for extended periods of time. Larger acoustic Doppler systems like ADCPs, shown in the upper right, can measure turbulence, particularly in energetic conditions, but because of their sampling characteristics, they will run into issues at high platform speeds and attenuate the energy at small scales. Both of these sensors are typically deployed for experiments, research cruises, or specific measurement campaigns rather than for persistent environmental monitoring efforts to measure small-scale turbulence. Arete's solution to meet the Navy's measurement need is an electromagnetic velocity sensor we call HANA. HANA is small and rugged, mostly made of metal with a few durable plastic and epoxy components. It has no moving parts or delicate appendages. HANA operates on the principle of electromagnetic induction, discovered by Michael Faraday and once used by him in an attempt to measure the River Thames discharge in 1832. The measurement principle involves ionic fluid, in our case water, flowing through a static magnetic field. This induces an electromotive force, a voltage, which HANA measures at an array of electrodes in the sensor tip. The dissolved ions in water act as tracers for small parcels of water, and the fluctuations in voltage are proportional to velocity. By sampling these voltage fluctuations at a higher rate and in a small region, we measure turbulent velocities. HANA is a simple sensor with no configuration necessary. Effectively, it is a low-noise, high-performance voltage sensor. HANA uses Ethernet for communications, allowing for long cable runs and easier interfacing to almost any modern computer. The sampling characteristics are competitive with existing small-scale turbulence sensors while also being able to resolve even highly energetic turbulence. HANA development is currently in Phase 2, Option 2. We are preparing our prototype sensors for a field measurement demonstration in early summer 2024 on a remotely operated vehicle, analyzing data from laboratory validation studies, and working to improve our sensor design for easier manufacturing. HANA's key features are its small size, low weight, it's about 0.8 kilograms or 1.7 pounds in water, simplicity, and durability. When we compare against the state-of-the-art in ocean turbulence measurements, the airfoil shear probe, we see HANA is similar in size, has lower power consumption, it's about 1 watt while operating, and is much more durable. HANA's performance is comparable to or exceeds the shear probe when looking at noise levels and spatial response. Turbulence, despite its environmental ubiquity and importance, is not something many people think about, but it is an extremely important parameter in the ocean and undersampled. We are focusing our transition activities on Navy and Navy-funded researchers, but hope to find programs which understand the importance of turbulence measurements and can support integration and long-term demonstrations of our sensor. We understand most researchers will also want to design their own validation studies. We are interested in working with you to develop a validation experiment or demonstration. Turbulence sensors are available from a few manufacturers, but this is a specialized market. HANA is a new capability within this space, combining the durability of acoustic systems with the performance characteristics of a shear probe. We think the best way to develop market share is to work with vehicle manufacturers to integrate HANA on their vehicles, making it available to both new and existing customers quite easily. This amortizes integration costs and allows us to access existing and future fleets of autonomous vehicles of all sizes. Because of its low power consumption, simple operation, and durability, we hope to see HANA establish ocean turbulence measurements as part of the standard naval oceanographic measurement suite. We designed HANA to be a product from the start, not a one-off research system. We are looking for partners who have funding for demonstration programs where we would handle low-rate production in-house and assist the customer in getting the system up and running on their vehicle. We're interested in collaborating on these demonstration projects and working with you to get the best data you can from our sensor. Arete's Maritime Sensing Solutions Group is based in our Arlington, Virginia office. We specialize in developing rugged, high-performance ocean sensors, communications platforms, and other underwater capabilities. If you have any questions on HANA or a challenging marine sensing need, please get in touch with us.